Okay, just give us a minute, try to set us on the live stream. All right, so that's a confirmation that we are already on. We're already online. Okay, that's a confirmation that we're already online. So let me be sure that we're there. Once I have that confirmation, we would start. Okay, I have confirmation that I am on YouTube now, so I can start. Okay, beautiful. So I think the feedback I'm getting is pretty okay. So I think I can run with this, all right? Okay, so good evening once again. You're on to Mama with Jarvis. And for close to 5 days now, or 4 days now, we've been trying to do a rundown of areas of mathematics and to see how we can bring grade 10, 11, 12 to the WAEC level. So what we're doing is actually a WAEC NECO level revision. And for today's class, I've added the grade 9 students to it for a very simple reason, because what we'll be considering is actually called numerical processes, and it's something that we expect our grade 9 student, that's JSS3, SS1, to be able to handle. All right, so we'll go straight away to our course for today. And as usual, we'll be using WAEC question papers to answer the questions. A quick reminder here that we are live on YouTube. So if for any reason, because of the class, you have an issue with your Zoom, you just go to YouTube, look for Mama with Jarvis. If you've not subscribed to my channel already, just look for Mama with Jarvis and go to the live section and you see the video running live and direct. All right, so let's hit the road. We'll start today's class by looking at WAEC 2021, WAEC 2021 OBJ, WAEC 2021 OBJ. We'll look at question number 1. Now, when we mention numerical processes, what comes to our mind or minds? What should we be thinking about? We're thinking of things like addition, subtraction, multiplication, division, significant figures, approximations, and the likes. And I'm trusting that by the time I take you through some questions, you have a clear perspective of what numerical processes is all about. So we take that WAEC here. I will start with question number 1. Question 1 says correct. Now this is the number we are to correct to. All right, let me write on the board 0.00798516. 0.00798516. And we are told to approximate this or correct to what? 2 significant figures, which we sometimes we'll call 2SF. Correct to what? 2 significant figures, 2SF. Now, for significant figures, it has to do with place value. What's the place value? Now, for numbers that are less than 0, pure decimals as it were, the first non-zero digit is what we treat as what? Significant. So not this, but this. This is now the first significant. Any digit that follows after this is also treated as what? Significant. So for two significant figures, we're going to treat these 2 digits. Now, the next thing we want to do is to use the concept of digit of interest and digit causing the approximation. The digit of interest and the digit causing the approximation. This is the digit of interest, the second, you are told of 2 significant figures, and this is the digit causing the approximation. If this digit is above, is 5 and above, we add 1 to these digits. So if we had 79 as it were, and we add 1 to it, we're going to get what? 80. So if I were to correct this to 2 significant figures, this will now be what? 0 point, first digit, second digit, 8, and what? 0. Because by adding 1 here, it makes this to become 0, and then we can take 1 to this and it becomes 8. So this is what we expect the answer to be if we are correcting this to what? 2 significant figures. All right. So that will be question number 1. Let's see if we have another one there. So just to be double sure, I think that's the only question in my check that is actually that level problem. Now, if that is done, we go to the next year, because usually these questions are usually very cheap, but they require you to have to do what? Quick thinking. Now, we go to the next year. This one is NECO 2020. NECO 2020 is OBJ again. And the first question of interest there is question number 1. And what does that question say? Express 0.0040752 to what? 3 significant figures. Okay, let's write that question quickly. So let's write that quickly. Let's write that quickly. Okay, now we're told to approximate this to 3 significant figures. To what? 3 significant figures. Remember that this is a non-zero, this is a pure decimal. And as such, to handle a problem like this, we start by looking for the non-zero digits, and that will be this. So 3 significant figures means that 3 digits from here. 1, 2, 3. So these are the 3 digits I'm going to use. Now, the last digit is what I call the digit of interest. And this becomes the digit causing the approximation. If this is 5 and above, we will now add 1 here. If this were less than 5, we'll add what? 0 here. So your answer becomes what? 408 or 408. Let's start with 407 plus the digit causing the approximation. And that will give me 408. So 3 significant figures, this will be what? 0.00408. And that takes care of this problem. That will take care of this problem. Okay. So, okay, this was question number 2. Sorry about that. This is question number 2. So let's solve question number 1. There's a question number 1 which I missed out. There's a question number 1 which I missed out. It says, express what in standard form? Express in what? Standard form. We have 1, 0, 0, 0, 4 zeros, and 8, 0, 0. Now, remember that in modern maths, there's a way we write numbers. If I use my 3-digit system, these 3 digits, and then these 2. So I'm going to write something like this. Are you seeing that? So what this means is that this number is 10 million and what? 800. 10,800,000. All right. So what is a standard form? A standard form is the expression of a number as a unit decimal. Now, when we say a unit decimal, what do we mean? It means that we are going to express numbers such that the highest digit I will see will be a unit. Because after the unit will be what? Decimal. So I'm going to be 1 point something, 0.00008. Then, how many steps have I taken to get to this level? For every whole number, the last digit, which is the unit digit, is where you start the counting from. So I'm going to start from here. 1, 2, 3, 4, 5, 6, and 7. So I have moved 7 spaces, which will correspond to 10 to the power of what? 7. So the first thing is to write this number as a unit decimal. That is such that the highest digit you see is a unit. Then count the number of steps you have taken to get to that position. So that takes care of that problem. All right. So let's quickly look at if we have other questions at that level. Check if we have other questions at that level. I think that's the only one there. Usually, in any exam setup, usually have just 1 or 2 questions in that setup. So the next one I'm going to take on is a theory question. The next one I will be taking on is what? A theory question. It's a theory question. So how do we go about this? It says, let's see where that one lies. All right, I think I may want to clean the board a little more so that I'll have enough space to accommodate the question. All right, I'm just going to clean these parts. A quick reminder here that this class is recorded. So if there are areas that you're not clear about, you can rewatch the video. All right, so the question reads thus. It says, okay, now, although in this question paper, you were told that you should use what? Logarithm table, but I'm going to solve this without using logarithm table. I'm going to solve this without using logarithm table. And wherever we can get to in solving this problem, we proceed from there. All right, so I'm going to change the question now. So this is, this should be NECO, I think. NECO 2019 theory. NECO 2019 theory question number 1. And it says, use logarithm table, but I'm changing it to without using log table. The square root of 0.0024 times 35,000 divided by 0.0105. Now, I have restructured the question so that I wouldn't use logarithm table. So let's see how we're going to solve this one. The first thing you want to do is to take care of the decimal places. Now look at this. This is where you need to pay very close attention. How many decimal places am I seeing here? Now, when I talk about decimal places, I would mean that how many positions can I count to make this a whole number? Bear in mind that my denominator B, my numerator and my denominator must both be whole numbers. In using this technique, my denominator and my numerator must both be what? Whole numbers. So how do I do this? I'll start by counting how many steps I need to make this a whole number. 1, 2, 3, 4. I will then check if I will still need the same number of steps here. 1, 2, 3, 4. If I count 4 steps here and I count 4 steps beneath, it means that both steps are counted. I count 4 steps means I have taken 10 to the power of 4. I count 4 steps beneath. It means I'm taking what? 10 to the power of what? 4. So I've done the same thing to up and bottom. So I can restore this to whole number. So this will now be what? 24 times 3,000, 35,000 all over 105. All over what? 105. What do I do next? If you check closely, I can divide this by 3. I'm going to get 8 here. I can divide this by 3. I'm going to get what here? 35. I can divide this by what? 35. Look at it. This 35 is 35. So what I'm going to get to be what? 8 times what? 8 times 1,000. 8 times 1,000. So that will be the square root of what? 8 times 1,000. 8 times what? 1,000. So this will give me what? The square root of what? Now look at this. We said that the concept of square is the concept of what? Pairing. So I can break this number 8. Think of two numbers such that I have a perfect square and another number. I have 8. How do I break 8 so that I have a perfect square multiplying another number? Can I get response to that? And how do I break 1,000 such that I'm having a perfect square and what? I have a perfect square and multiplied by another number, a non-perfect square. Can I get response to that? Let's start with 8. How do I break 8? So I have a perfect square and a non-perfect square. And I look at 1,000, a perfect square, and what? A non-perfect square. Can I get feedback quickly? Right. Somebody helping us out. Okay, so this will be for 8. I'm going to get what? If you're using the, let's see. All right. Okay. Yes. I wanted to check if I have feedback from those watching online via YouTube. So let's see what we have. Let's see your chat. 4 and 2, very good. For 8, we're going to have 4 and 2, so that will be 4 times 2. Okay, for somebody who's chatting online, I've said that we are solving without using logarithm table. I have deliberately twisted the question to accommodate the class I want to have. Do you understand? Thank you very much, Livinus Jacob. I just did a twist on the question so that we wouldn't use logarithm tables. I understand what you're talking about. Times 1,000 will be what? Can somebody help us? 1,000 will become what? Okay. 1,000 will become what? Somebody helping us out. What two numbers can I multiply? Beautiful, 110. Beautiful. So I'm going to have 110. Now look at this. I can find the square root of 2, is that not? Or 4, that will become 2, is that not? I can find the square root of 100, that will be what? What is the square root of 100? That will be 10. The square root of, I can't find the square root of 2. Now, look at 10. I can break 10 into 2 and 5. Is that not? I can break 10 into what? 2 and 5. Now, remember we said that from our grade 7, square root means pair and take 1. I can actually now pair these two and take 1. So that will be 2 times 10 times 2, and I'm left with the square root of 5. Are you seeing that? So what is 2 times 2? That will be 4 times 10. That will be 40. Now, what is the square root of 5? Now, there are certain numbers you must know their square roots. For instance, you should know from memory the square root of 2, the square root of 3, and the square root of 5. Square root of 2 should be 1.414, if I'm right, 1.732, and it should be 2. What was that? Is it 2.2, 2.236, if I'm right? Confirm for me. Now, these are things you ought to, let me see the chart. Okay, beautiful. Now, these are things you ought to know. So you may want to copy these down. You should know them. You should have them handy. You don't need to check a calculator to get this value. So these things should come handy to you. So with that, I'm going to have something like this. I have to clean this part. And what I'm going to have will be something like saying, okay, times 2, okay, let's say times root, or say 40 root 5, and that will be equal to 40 times 2.236. 2.236. What does that give you? That would be like saying 4 multiplying this. So I'll just come somewhere. Remember that I don't want to use my calculator. So if you're using your calculator, you most likely will be faster than this. 4, a carry of 2. 3 times 4 is 12, plus 2, that's 14. Please confirm if I'm right. A carry of 1, 2 times 4 will be what? 8 plus 1, 9 points. I'm not carrying anything. 2 times 4 will be what? 8. Oh my God, that's right. So that will be 8 times 10. Remember, this 10 in this setup will move this decimal place forward. 10, if you're multiplying by 10, it moves the decimal place forward. It makes the number to increase in its place value system. So this becomes what? 89.44. So we've actually solved this without using our calculator. And that's the most important thing you must take note of when you're doing numerical processes. A lot of the problems we're going to see under numerical processes, at least at their fundamental stage, will not require the use of calculators or four-figure table, okay, except where otherwise stated. So that's the solution to that problem. And I think that's the last question I have there. Now notice that I'm not solving word problems yet. When we come to word problems, it will be a different ball game, right? So we're done with that, and we can yet go to another question. Okay, yes, sorry about that. I can see your feedback. We have a little challenge with our lighting, so we may just have to manage what we have. I've had to make, looking at the condition I have around me, this appears to be the best condition to have this class. So I'm very sorry about that. Sorry, I should have mentioned that at the beginning of the class, all right? Okay, so with that said, maybe I make use of this part of the board. And then we go to NECO 2019. NECO 2019, I'll just put that here. And this is this should be GC, this should be November, December. So let's just say November. It's OBJ. And so let's look at the questions that have to do with numerical processes. Okay, quite a handful of them. Usually in this exam, usually have 1 or 2 or 3. So I'll start with number 1. It says express. This is a number 48560 in standard form. Express this whole number in standard form. Express this whole number in standard form. So I'm going to use my 3-digit system and I'm going to rewrite this. So this will be 48,560. It's important. Take note that we rarely use comma in modern maths. We use what is called the 3-digit system. 3-digit and a space. So take note of that one. We said that for a whole number, the last digit is where we start to move the pointer from. So if that's understood, I start moving from that point 1, 2, 3, 4. We said that the unit decimal, I prefer to write the unit decimal first without adding the 0. And then I check how many steps backwards or forward I have counted. Now, if I move backwards, I am trying to make a big number small. So it will be 10 to the power of a positive value. If I move forward, I'm trying to make a small number big. So I'm exerting so much energy, it becomes what? Negative, right? So that'll be times 10. Because this is a big number, I don't need any extra efforts. So what do? Just count it jejely because I'm moving towards my left. So that'll be 1, 2, 3, 4. So that'll be 4.856 times 10 raised to the power of 4. And with that, we are done with that problem. You can see that I'm dancing. That means I'm happy that I've solved that question. All right. So we go to question number 2. Question number 2 is a test on fractions. Question number 2 is a test on fractions. Sorry, I have to check my live YouTube stuff so that to see if there are questions or things I need to address. All right. Question number 2 is a question on fractions and board maths. So board maths forms alliance with fractions. All right. So let's see what happens. It says 2, 1/3 plus 4/5 divided by 2/5 of 1/4. Now, you may have heard of the concept of bid maths and board maths. Okay, this is 2 whole number. I can barely see that on the screen. There's something we call bid maths and board maths. In application, they are the same. So I'll just stick to my board maths. This is something we're already used to in this part of the world. Some books will say bid maths. All right, now look at this. Bracket off. So I treat off first, and that will mean that I'm going to treat this area first. And once I've treated that, the next thing I want to do is to take care of my division. And when I'm taking care of my division, I cannot take care of my addition. So it's just an acceptable way mathematicians have agreed that we should handle problems of this magnitude. All right, let's see if we have any comments. All right, no comments yet. All right, so what do? I'm going to handle this part. So I'll write 2 whole number 1/3 times 4/5 divided by 2/5. Maybe I should create a bit of space there. So I don't know, maybe some of us might have an issue with seeing. Let's clean this part so I can move the question this way. So we'll have a full area to do the work. All right, so I'm picking it from this point. So I'm going to have 2 whole number 1/3 plus 4/5 divided by 2/5 off. I still reserve the off and then change this to what? Improper fraction. Anytime you're going to multiply or divide, you must keep it in improper mode. We multiply and divide in improper mode, but we add and subtract in what? Mixed mode, right? So this will be what? 5/4. I'll deal with this. So this will be what? 2, 1/3 plus 4/5 divided by what? 2/5 times what? 4 times what? 5/4. Beautiful. Now, remember that this division here is only affecting this. Take note of that. It's only affecting this. So my next line will read so sorry about that. Okay, so let's get back. Okay, so I don't know at what point in time we lost contact, so I'll just go back a little. I was saying that this division will only affect this. So with that, this will be this times 5/2 times 5/4. So what do? We try to cancel out. This will cancel this. In cancelling out, numerator will always cancel, numerator will cancel denominator. Now we cancel out again, and this, we cancel this. Are we together? And so we're left with what? 2 1/3 plus 5/2. Now, students sometimes will want to change this improper fraction to add. It's an OBJ question. I wouldn't query about that. But I think the appropriate thing to do is not to run away from what I call your mixed mode. So I'm going to stick to my mixed mode. 1/3 plus what? 2 over 1/2. 5/2 means 2 over 1/2. How is that gotten? 5/2. How many 2's can I get from 5? 2. What is remaining? 1 out of 2. How many 2's can I get from 5? 2. 2 times 1, 2. 2 times 2, 4. And I'm left with 1. So at this point, I'm going to add this one. 2 plus 2 will give me 4. And then I can now take care of the fractions in addition mode. So this will be 6. The LCM of 3. The LCM of 3. The LCM of 3 and 2 will be 6. And so if we do that, this becomes 2 plus 3. And that will give me 5/6. All right, that is what our answer is going to be. I'm trying to confirm if there's something in the question I have missed. Okay. Okay, I think I lost. Please, let's take this question again. I think I lost track of something. I don't know if that is what is causing my problem here, but it's good for us to confirm. Oh, okay, I think I lost track of something. Let's correct that. Let's correct that quickly. This is 2 1/3 plus 4/5 divided by, remember I said that off means do this first. Do this one first. You see, sometimes when mathematicians leave a rule, it's always good we try not to be too smart. So I think I was trying to be smart, but I've just discovered that what I have done is wrong. Now, this is off, means treat this first. So this would have been what? This would have been what? 2. This 5 will go with this 5. And this would have been what? 1. So divided by 1/2. So let's see if that would correct my mistake. The error came from me. That would be 2 1/3 plus 4/5 times 2/1. All right. I think what I'm doing now is correct. So this will be 2 number 1/3 plus 4 times 2, 8/5. I was expecting somebody on the chat to have drawn my attention to that. Let's see if somebody had spoken earlier. All right. And this will be, give me what? 2 number 1/3 plus 1 number 3/5. Beautiful. Now I am correct. So what is the LCM? 2 plus 1 will give me 3. The LCM will be 15. 3 and 5 are prime numbers. So we can just pick the LCM as multiplying 3 times 5. So this will give me 5. 15 divided by 3 will give me 5 times 1 plus 15 divided by 5 will give me what? Divided by 5 will give me 3 plus 3, that will give me 9. My answer becomes what? 3 number 40/15. All right. So you can see that sometimes when we try to be smart, we also must ensure that we are not breaking the rules. Okay, thank you. It's like somebody on the YouTube had noticed that issue. Thank you very much for the observation. So that's for this problem, and we are done with this one. Okay, there are more questions coming from that here, so we'll take them now. We'll take them now. So we can go to question number 5 of that same year. Question number 5. Okay, let's give ourselves a minute or two to breathe, to catch our breaths. All right, so let's go on. Let's go on. Let's go on. Question number 5 says what? Arrange the following fractions in descending order. Arrange the following fractions in descending order. What does it mean to descend? It means to start from the highest point and go to the lowest point. To descend means to start from the highest point and then go to the lowest point. Okay, so if we're going to be doing that, it would mean that we need to look at what fractions we're considering. 4/7, 5/7, 2/3, and 3/5. So, how do we solve a question like this? Now, there are different methods you've been taught. Different methods you've been taught. But when you're given a problem like this, the first thing you try to identify the prime numbers of the denominators. So, as some people say, look for the LCD, fine. That's okay, look for the LCD, fine. And LCM and LCD are the same. It is called LCD when it's used as that of the denominators. When we're treating fractions, we use LCD. When we're treating numbers, we use LCM. Just semantics, as it were. Now, look at this. I look out for unique numbers. I can see 7, I can see 3, I can see 5. This is what the LCM is going to be. 3, 5, and what? 7. So 3, 5, and 7 will be my LCM. All right. So now, look at this. This will be 4/7, 5/7, 2/3, and 3/5. Okay. Now, you can start by multiplying this. That's the approach I use. I multiply this by 3 times 7 times 5. I multiply this by 3 times 7 times 5. Sorry about the order. I multiply this by what? 3 times 7 times 5. And I'm going to multiply this by 3 times 7 times 5. The other methods I know, I just chosen to use this method. Now, if you look at this, I can cancel this. I'm going to have 4 times 3, 12 times 5, 60. I can cancel this. I'm going to have 3 times 5, which is 15, times 5, which is what? 75. Remember that because it's an OBJ exam, you're free to use your calculator, but you really don't need your calculator. Now look at this. We're going to have 2 times 7 times 5. This will be 70. Because 2 times 5 will be 10. 10 times 7 will be what? 70. Okay, look at this one. This will be 3 times 3. That will be 9. 9 times 7, that will be what? 63. So, remember that we are told to arrange in what? Descending order. So, the highest is what will be number 1. So, this will be number 1, 75. This will be number 2. This will be number 3. And this will be number 4. So, if you're going to arrange the fractions now, you're going to have 5/7 first. Then you're going to have 2/3. Then you're going to have 3/5. And then finally, you're going to have what? 4/7. So I think in this year, they were generous enough to give you 3 questions. It's a rare occurrence. It's a very rare occurrence to have up to 3 questions like this. So I think that's about all for that. But let's just check through to be sure that there's no questions we have left out. Okay. Right. There's another one on word problem, but I said I'm not solving word problem today. Right. So that's taken care of. So we go to another year. This one will be 2019, WAEC 2019. WAEC 2019. I hope you enjoy yourself. This aspect of maths will usually require more of your thinking, how quickly you can think of an answer, right? So we go to WAEC 2019. Objective, what question is that? Let's see. Question number 1. So let's look at question number 1. Express correct to 3 significant figures 0.003597. Express correct to 3 significant figures 0.003597. I got that right the first time. 0.003597. So what? 3 significant figures, 3 SF. 3 significant figures. Remember we said for a pure decimal, your first non-zero digit is your first significant digit. So you count 1, towards your right, 2, and 3. So it means that these are the digits I'm going to be considering. So the last digit is what I call the digit of interest. And then this digit is what I call the digit costing the approximation. This is a digit that will cost the approximation. So because this digit is 5 and above, 7 is a number that is bigger than 5. So we would add 1 to this. So I'll just come somewhere here and say 359 plus 1, and that will give me 360. Is that not? So in writing my answer, I'm going to have 0.00360. 3 digits, interest, costing the approximation. And that's what I'm going to get as my final answer to that question. All right. There's yet another one. Question number 4. Question number 4. Question number 4. Question number 4 says, simplify and then correct to 3 significant figures. Now look at the question. 27.63 all squared minus, or 27.63 squared minus 12.37. I wonder why the emphasis on this bracket. I don't think that would have been necessary. All right. Now, 27.63 squared minus 12.37 squared. So how do you do that? How do you do that? How do you do that? Now, we're going to be borrowing in knowledge from, this is that sometimes questions are not absolutely on their own. If you look at this carefully, there's a squared here, there's another squared here, and there's a minus. Can someone tell me what term comes to mind? Can I get that quickly on the chat? There's a squared here, there's a squared here, and then there's a minus here. Can I get a response to that? Can we get a response to that? There's a squared, this number is squared, this number is squared, and then I'm seeing a minus here. What term readily comes to mind? Can I get responses to that? Waiting for your feedback. What's another word for minus? What's another word for minus? Or what's another word for subtraction? What would that mean? Hello, is somebody there? Somebody say something. Okay. The minus will suggest what? Difference. And then a number to a power of 2 is what? Square. So I'm seeing squared here. I'm seeing square here. Take away good, that's fine. That's beautiful. Tobe, thank you very much. Now, I'm seeing squared here. I'm seeing squared here. I'm seeing difference here. So if I put the words together, I'll have what is called difference of 2 squares. Now, you must identify this in a problem. You must do what? Learn to identify this in a problem. Difference of what? 2 squares. Okay, somebody else is saying something. All right, let's see what you're saying. Diminished. Okay, all right. Okay, fine. That's good. So I put these 2 terms together and I've called it difference of 2 squares. That is 2 squares or 2 numbers that are squared that are separated by minus or carrying out subtraction of 2 numbers that are squared. Now, there is a formula for it, or there is an understanding for that. A squared minus B squared will be equal to what? The difference of 2 squares can be expressed as what? A plus B into what? A minus B. It means add them, get the answer, and multiply it to when you subtract them. So anytime you see this kind of arrangement in maths, what you should do is to take this, add it to this, get the answer, then take this, remove this from this. Whatever you get finally, you do what? You multiply them. Do you understand? Right, so this will be equal to 27.63 plus 12.37 multiplying by 27.63 minus 12.37. So if I add this together, let's come here, 27.63 plus 12.37. Can we do the maths together, please? 27.63 minus 12.37. Okay, do that quickly, please. Could you do the addition and the subtraction for me? Add it up. You can use a calculator, but usually in a theory exam, you'll be told to do this without using calculator. So you need to know how this is done. That's why I've taken some more time to explain this. Is that okay? Right, so add this together, what do you get? Subtract this, what do you get? I'm waiting for my answers. Somebody on the chat, please. This is where you do the work now. Is that okay? Beautiful. Somebody has gotten the answer, 40. I totally agree with you. Esther, best man. Wonderful. That's nice. That's good. That's a grade 9 student. That's nice. Okay. Now, can we do the subtraction here? I'm waiting. So it's not me doing all the talking. Beautiful. So let's see. And that's okay. That's a grade 11, I think. This will be 6. This is 2. I'm gonna write with that. This will be what? 5, 1. All right, 15.26. Good. That's nice. That's very, very nice. So you're gonna have 40 times 15.26. What would the answer be? Now, some of us might want to punch our calculator, but I'll give you a little technique you can use. This is 10. This 40 will be 4 times 10 times 15.26. So this will push this decimal point 1 by 1 step. So I'm going to have 4 times 152.6. Now, please, you can use your calculator to do this. I'm only going through this trouble. I'm not a calculator person. I try as much as possible to avoid using calculators. So hence, I'm kind of old school when it comes to this. All right, so I'm going to go 152.6 times 4. That'll be 4, a carry of 2.0. 2 times 4 is 8 plus 2. All right, you already have an answer. That's good. That's a carry of 1. 5 times 4, 20 plus 1, 21. A carry of what? 2. All right. I think I've seen the correct answer there, and you're correct. That's 610.4. Beautiful, beautiful, beautiful. You've all done very well today. Very, very good. Very, very good. Very good. All right. I think that's that for that year. I can't see any question in that neighborhood anymore. So maybe let's see if we can take 1 or 2 more years. I don't know how that will pan out. Okay, let's give ourselves like 2 minutes to stretch out. Let's stretch out, let's stretch out, stretch out, stretch out, stretch out. 1 or 2 minutes to stretch out. Okay, this one was a long one. It was a very long one, very long one. So this is, don't worry, I'll just write that on the board just to get us ready for the next question. Okay. If you're set, just tell me yes. If you're set, tell me yes. Okay, best man is ready for me. Who else is ready for me? Okay, Tobe is ready for me. Who else? Who else is ready? Isaac is ready. Okay, who else is ready for me? Can I get one more person so I can go on? One more person. Okay, Deborah. All right, so let's continue. All right. Okay, so this is WAEC 2017. So those of you in grade 9, you discover that you can actually solve WAEC question papers. So let me give you a little trick. When you pick WAEC or NECO question papers, look for the questions you can solve and solve it. You don't need to be in grade 12 to be solving WAEC question. You can start now. If by grade 10 you can solve up to 20, 30 questions, you see that your confidence will grow. All right, that's nice. All right, so we will start off with question number 1. I think, right, it says express. Now, I'm going to leave you to do this, and then I'll solve. It says express 0.0000407 and correct to what? 2 significant figures. Can somebody help us with that? Express 0.0000407 to 2 significant figures. Can I get an answer to that? Somebody telling us? Okay, that's nice. Nice to know. I'm waiting for feedback. I'm waiting for feedback. So 2 significant figures. Okay, just drop the chat. Drop it as a chat. Just chat the answer. I'll see it. I want you to do this one. You know, I've been doing all the talking lately. So let's see how many of us can really solve this. So you can just drop the answer as a chat. Okay. Now, this is a question you shouldn't spend more than 15 to 30 seconds solving this. In fact, beautiful. All right. Somebody has gotten the answer. Somebody called Jack. All right. So the technique is this. For a pure decimal, beautiful. The first non-zero digit, is what we're going to consider. So after that, any digit that follows after it is okay. Any digit that follows after it is okay. So once this is significant, automatically this one becomes significant. That's how it happens. So this will now be what? 40. Now, digit causing approximation, digit of interest, and this is causing the approximation. This is 5 and above. So what do you have? We are going to add 1. That will be what? 41. So I'm going to put that here, and this will be 0.000, 4 zeros and 41. Beautiful. Thank you very much. We go to question number 3 now on that same year. This one you're going to solve yourself too, and then I'll come in to help. It says we should evaluate. What are we asked to evaluate? 3 whole number, 1/4, multiplied by 1 whole number, 3/5, divided by 11 whole number, 1/3, minus 5 whole number, 1/3. Now I'm going to give you 60 seconds to solve this question. Your time starts now. In 60 seconds, I want an answer. Okay, I'm waiting. Is there an answer for me? Is there an answer for me? Okay, while we're trying to work that, now watch this. This is multiplication. So to do this, you must change this both to a proper fraction. That's the first thing you want to do. So this will be 13/4, 3 times 4 plus 1 times, this will be what? 5 times 1 plus 3, 8/5, all over. Now, watch this. Whole number minus whole number is 6. Fraction minus fraction is what? 0. So you don't need to waste time here. You don't need to do what? Waste your time here. So that settles that. And with that done, I can take care of the top. 1 and 2. So this will give me what? 13 times 2/5 divided by 6. Wow, that's nice. So I guess you can see my board very well now. Yes, we'll be making use of assisted lighting, but now the owners of the correct lighting have just given us the correct lighting. So you can see that our board is brighter now. Right, thank you. Okay, now look at this. This is what you're going to have. And what would this be? This will be what? 13 times 2/5. This division returns to times and becomes what? 1/6. Yes, it's so good now because the owners of the light have just given us the lights. So this will now be what? If you watch carefully, 2 can divide this. I'm going to get 3 here. 2 can divide, I'm going to get 1. And that will be 13/15. So my answer will be what? 13/15. So that's for question number 3. Let's see if we have other questions that are like that too for us to handle. If not, we go to a new question here. All right. Okay, 1 minute, please. Okay, let's see. Let me see. 1 minute, please. Let's see those of my charts. All right. Okay. Sorry, those of you on YouTube. Sorry, I had to take care of something else, but I have it back now. Okay, thanks. Thanks a lot. Thanks a lot. Beautiful. Okay, now we're going to take another question. I'll clean off everything now. I'm going to clean off everything on the board. I did say yesterday that we're going to stretch for a little more time. Please, I hope you don't mind. So sorry about that. Just today will be the last day of this series of learning. But next week, we're going to continue. I talked about what is called the Midnight Sun Project, which will be my class every day, 8 to 9. So I'll be having a schedule drawn. So every day, 8 to 9. My focus will be on grade 9 and 12. Although for the grade 9 class, anybody can join. For the grade 12 class, anybody can join, depending on the topic we're going to be handling. We're going to be the Midnight Sun Project. We're going to be every day from 8 to about 9:30. It's going to be WAEC and junior NECO level questions. We'll just be solving questions. So if for any reason you miss the class, you can go back to my YouTube channel and rewatch the class. It's not a problem. Thank God for technology. It's not a problem at all. If you miss a class, just go to my channel and rewatch the class, right? Okay, so let's look at this one is WAEC, November 2015, and it's OBJ. And so let's look at some of the arithmetic questions there. Now, let's see. I'm trying to avoid a word problem, so I wouldn't take word problem. Maybe some other time I would handle word problem. So I wouldn't take word problem, so I'm looking at that. And from what I can see, there seem not to be any question there. I also will do a separate video on statistics. I'm trying to check. Wonderful. We don't have any question like that here. So we'll pick the next one, June 2012. We'll pick the next one, June 2012. Yes, we have one there. So this will be June 2012. It says express to 5 significant figures. You're going to do this yourself. Number 1, 302.10495. All right, 302.10495. It says to 5 significant figures. Wow. Can we handle that? To 5 significant figures. Can we handle that? So let's do that. You have 30 seconds to do that. 30 seconds. Okay, I guess we have an answer now, right? So now for this, you have whole numbers mixed with decimal. So in this setup, you must start from the first digits. That's where you start the counting from. 1, 2, 3, 4, 5. This is where you're going to stop. So the digits of interest is this. The digit causing the approximation is 4. Because this is less than 5, you add 0. When it's less than 5, you add 0. So that will be 302.10 plus 0 to the last digit. And this will give you 302.10. Now, adding this 0 is very important. If you don't add that 0, what you have done is 4 significant figures. Take note of that. Now, let's look at this. Question 3 is testing your knowledge of ratio. In 1995, the enrollment of 2 schools, X and Y. These are 2 schools, X and Y, and their enrollments were 1,050 and 1,190. It says find the ratio of the enrollment of X to Y. I hope you know that's how you write ratio. So what they mean is that reduce these numbers to the lowest step. So we're going to have 1,050 to 1,190. Now what do? You divide by 0, you divide by 0, is that not? What else can divide? 7 can divide this. That will give me 15. 7 into this will give me 1. I'll have a 4. And that will be what? 19, is that not? So if I divide this with 7, because 0 will cancel 0, or more like I divided both sides by 10. So the effective thing is to cancel with that, right? So now I'm going to have 15 here, I'm going to have 19 here. So the ratio of X, the enrollment X to Y will be what? 15 is to 19. All right. Okay. So that settles that question. So if that is done, we can look at a question that tests conversion. This is WAEC 2011, June, OBJ. Okay, somebody say something. Let's see what that is. Okay, so it says if 112 naira exchanges for another currency, this calculates the value of 1D in naira. So we're told that this is equivalent to this amount. Now we have to find what will 1 of this be equal to. How do I get 1 of this? So it's very simple. 112 is equivalent to 14.95. This is actually testing your knowledge of direct proportion. Direct proportion. That is to say, if this currency, if I increase the value of this one, it will increase this. If I increase this, it will increase this. If I decrease this, it will decrease this. So it's a direct proportion question. That's what it's testing. So if this is equivalent to this, what will this one now be? I'm thinking, what would it be in Naira? So where I'm having that thought, I can change it to X. And I can use my knowledge of ratio to handle this. I can now say 112 over X is equal to 14.95 over what? 1. Because it's direct proportion. Now with this, I can say that what? X will multiply this. So 14.95 will be equal to 112. Which means that if I divide both sides by 14.95, I'm going to have X equal to 112 divided by 14.95. So some of us can use our calculator, or some of us might use our calculator, or we can get an approximate value for this. So I will simply say this is 112. There are 2 decimal places here, so I can account for them. 1, 2. What I do to bottom, I must do to top. If I move this by 2 decimal places, I will multiply this by 100 or add 2 zeros to it. So this becomes what? Divided by 1495. So what will my final answer be? Okay, so what will your final answer be? We can actually divide by 5. I know that this number is divisible by what? 56. So that's like 7. 7 cannot divide this, so it might be problematic for me, but I can approximate. I know the answer is close to 8 will be too much. Beautiful, beautiful. Yes, you punch your calculator, that is correct. So that will be 7 naira 49 kobo. That will be what? 7 naira 49 kobo. The answer will not be 7.491. There's a catch here. Remember that every currency calculation is to 2 decimal places. Please write that somewhere in your book. I'm going to repeat that, and I want you to write it somewhere in your book. Every currency calculation is always to 2 decimal places. And the reason is this: when you're talking about pounds, we're talking about dollar, the decimal part really represents pence or shillings. It's always to 2 decimal places. Take note of that. That's a very technical idea I passed across. All right. So I'm trusting that after this class, anytime you see standard for decimal places, ratio, and the likes, you can't fail it. But it will be a walkover for you. Right. The next question is from 2004. This should be WAEC. This should be November exam. And this should be OBJ. Right? OBJ. It's really question 1 and question 2. So question 1. Express 0.015849 to what? 3 significant figures. Can I have this answer in 20 seconds? 20 seconds. Can I have that answer in 20 seconds? In 20 seconds, can I have an answer? 20 seconds. 20 seconds. Who is going to be that smart? Who is going to be the midnight son or daughter in this class? 0.015849 to 3 significant figures. Wonderful. That's correct. Jaden, awesome. Good. I think that should be grade 8. Awesome. That's a very nice one. All right. So we said that for significant figures for a pure decimal, you start from here. 1, 2, 3. This is the first non-zero digits. So 1, 2, 3. Is that the video? Okay. I think I'm seeing the correction now. All right. I think I was just carried away. I was okay. Beautiful. I was carried away. Now let's see what the correct answer is. All right. Now, 1, 2, 3. Digit of interest. The digit causing the approximation is not up to 5. The digit causing the approximation is not up to 5. So what do? It means you're going to add what? A 0. So it will be 158 plus 0. Are you seeing that? So this will be 0.0158. That's what the answer will be. And not 9. Although that was a very good one. Very good one. I think I'm pretty impressed with that effort. Thank you very much. All right. Now, question number 2. Question number 2. Now, we are told to simplify this. One whole number, 3/5, plus one whole number, 1/8, times 16/45. Can I get this done in 30 seconds? 30 seconds to 1 minute. 30 seconds to 1 minute. Somebody helping us out. One whole number, 3/5, plus one whole number, 1/8, times 16/45. Somebody helping us out. Somebody helping us out. Who is going to be the king of this dynasty? Okay, somebody has an answer. All right, I'll just note that answer somewhere. Can I have that answer? Okay, all right, we're getting varied answers. So let's look at this. We start by writing our board maths. We keep your answers coming. We'll start by writing our board maths. And then by our board maths, we need to do this first. And to do this first means I have to turn this to improper fraction. So this will be what? 1 whole number, 3/5, plus 9/8. Is that okay? Times 16/45. So what do? We want to cancel out. 8 go here, 1, 8 go here, 2. 9 go here, 5, 9 go here, 1. So what do I have? We're having 2/5 left. So that will be 1, 3/5 plus 2/5. This is the same thing as like fractions. There's a concept called like fractions. So for like fractions, I hold the denominator and add the numerator. So this will be what? 1 plus what? 3 plus 2 is 5. 5/5 is what? 1 plus 1, and that will be 2. Okay. Okay. Thank you very much. We just got a response from, okay. Oh, so sorry. We didn't see this. Oh, thank you very much. Some of us on the live chat. Thank you, Bolaji. Your answer is correct, 0.0158. Okay, please, but maybe you may want to tell us where you're joining us from. Is that Port Harcourt? Is that Lagos? You just want to tell us where you're joining us from. Okay. All right, let's continue. Some people are already telling me that they want to go. Don't worry, we'll soon be done. You know, yesterday I asked for extra 30 minutes. I asked for it. Don't worry, after today, it will be till Monday evening. All right. Right. Okay, let's see. Somebody's saying something on the chat. Let me confirm. Okay, so those who said 2, you're spot on. All right, so you're going to do this one for me. Now I'm going to write the questions down, and I want you to solve them. This comes from NECO 2003 OBJ. I'm going to write the questions on the board, and I want you to solve them. I want you to try your hands on them, just to prove to me that you're flowing what we're doing. Now, question 1 says, express this number to 2 decimal places. So it is 0.0099687 to what? 2 dp. 2 dp. Oh, sorry about that. To 4 dp. 4 dp. 4 decimal places. Take note, decimal places is not the same thing as significant figures. So be careful here. So to 4 dp. That's question number 1. Question number 2 says, or question number 3 on that here says, simplify 2 whole number 1/4 minus 4/15 divided by, we saw the question like this before, 1/3 of 4/5. 2 whole number 1/4 minus 4/15 divided by 1/3 of 4/5. Right? Oh, there's even another one. Question number 6 says, now look at this. Okay, let's clear these 2 first. We won't go beyond this question paper. We'll call it a day once we're done with this. We have 4 questions here. It's a very strange one. Okay, I think you can do this. Question 6 says, correct. Let's write it on the board. Correct 5.0962894 to 3 significant figures. You ask to correct that to what? 3 significant figures. Correct 5.0962894 to 3 significant figures. So I'm going to give you a minute or 2. Give me your answers. In the chat, number 1, just say number 1, put the answer. Number 3, put the answer. Number 6, put the answer. Then you score yourself. Oh, wonderful. Okay, that was fast. All right. Okay, that's good. That's good. All right. Okay, so let's solve together. Number 1. So 4 significant figures. So what do you have? 0.0099687. So you count. Now, to 4 decimal places. Pardon me, 4 decimal places. So that will be any point that any position after the decimal point to my right is treated as a decimal place. So decimal places, whole number places. Beautiful. I think praise God, you have the right answer. That's nice. I think so. So this will be what? I will count 1, 2, 3, 4. So these 4 places are the 4 decimal places I will consider. So this becomes the last digit becomes a digit of interest, and this is the one causing the approximation. So what do? I will come here and write 99. Because it's decimal places, I'll put this one 0, 0. And then I'm going to do what? Because this is 6, I'll add 1 here. So I'm going to have 0, 0.010. So my answer will be what? 0.0100. Please, if you write 0.01, which I'm very sure the option will be, if you do that, you're going to get the answer wrong because we want to see 4 decimal places. Is that not? So let me do question 6, because that's a very quick one to handle. Correct? 5 point what? 5.0962894. So what? 3 significant figures. For significant figures, we start from this, the whole number digits, and then we begin to count 1, 2, 3. So this is the digits of interest, and this is the digit causing the approximation. So what do I have? This is above 5. So I'm going to have 5.0909 plus 1. So that will be 5.10. Please take note, you must put the 0. If you fail to put the 0, it means you have said that this problem is what? 5.1. Take note of that. So this will now be what? 5.10 to what? 3 significant figures. All right, so let's do this one. Now, how do we do this? How do we do this? This will be what? 2 whole number, 1/4 minus 4/15. Remember the off. Divided by, off means treat this one first. So I'm going to put a bracket there. 1/3 times 4/5. I see that. Now the next thing will now be what? 2 1/4 minus 4/15 divided by what? 4/15. Is that okay? This will now be what? 2 1/4 minus 4/15 times 15/4. Is that okay? So this will cancel this will cancel this, and my answer will simply be what? 2 1/4. If I've done that correctly, my answer will be what? 2 1/4. All right. So if you got that answer, can I see a response to that? If you got that, let's get a response to that. Okay. So let's do that. With that sorted out, let's do the last question for tonight, which is question 7. So once we're done with that, we can call it a night. That's the last question for question 7. Question 7 will be the last question we're going to handle, and then we can call it a night. All right. Now, it says the difference between, now this is the number given, the difference between, okay, let's write the question now. The difference between 0.005 348 correct to 3 significant figure and 0.0001 5384 correct to 4 decimal places is the difference between 0.005348 correct to 3 significant figures and 0.005384 correct to what? 4 decimal places is. So can we do that? Can we do that? And tell me what your answer is. That's the last question for tonight. Can we do that? All right. So is somebody giving me the answer? Okay, somebody giving me the answer. So step 1, you need to make 0.005348 to what? 3SF. And then you need to make 0.005384 to what? 4 dp. Whatever you get, okay, we already have an answer. Okay, 2 answers, beautiful. So we just need to confirm which answer is correct. All right. So for this one, to 3 significant figures, it will be 1, 2, 3. Digit of interest, digit costing approximation. So this will be what? 0.00535. Is that not? Now, this one to 4 decimal places will be what? 0, 1, 2, 3, 4. Digit of interest, digit costing approximation is more than 1, it's more than 5, so it will be what? 4. So this will be 0.0054. Is that not? So we're going to subtract. This is bigger than this. So it will be 0.0054 minus 0.00535. So I'll put a 0 there. And when I subtract, this will be 5, 0, 0, 0, 0. So the first person there, best man, I think, Esther Bestman, I think she got it right. 0.00005. That's the correct answer to the problem. All right, thank you very much for your patience. I really want to thank you so much for your patience. A lot of us were already going tired, but you really need this kind of stamina if you're going to prepare for any examination. Beyond being taught well, beyond knowing it, you also need what? Stamina. Stamina is crucial to your doing well in any examination. So we're going to call it a day now. And like I said, we're going to start off the Midnight Sun project, and that will start next week from Monday through Friday, 8 to 9 o'clock. A schedule will be drawn up to tell us what grades we'll be meeting with, but technically I'm looking at, or majorly I'm looking at grade 9 and grade 12. So others can freely join. It's a passion, it's a passion thing. You can be in grade 7 and be learning grade 9 thing. Learning today has evolved. So thank you very much for your time. Have a blessed night rest and see you soon. Mamu will return. Bye. So, thank you very much for your time.